page here points to the optics page here, and these point to each other, and then we have to point those to each other. And this becomes a big tangled mess all of very quickly. So we're not going to do that. Instead, we're going to have one persistent place on the web with a URI that's never going to change, that's about optics, and we're going to assert that the topical pages on optics from all these other places, or any other places on the web that want to point to it, mean the same thing when they say optics as we mean on the optics topic pages of all these various scholarly publishing resources. So that's the idea, is that we have one place where a concept is defined and there's a bunch of information about it and a bunch of resources about it that anyone can go pull from it and get pointed back to, so that we're always asserting we talk about the same concept from one stable URI on the web. But if you noticed, back on the DBpedia page, not all the sources in my slide here are listed in the resources page. SPIE is, and OSA is, IOP is, but the AIP page isn't. Why not? They have not backlinked their data by adding a reference to Wikipedia. In order to get in the DBpedia page and have stuff pointing back to your collection about optics, you have to add a reference or a backlink so that when the crawler comes back through, it adds the backlink from the Wikipedia page to the DBpedia page, so that people going to DBpedia and extracting resources from it get pointed to your resource or reference on whatever the topic page is. So this is good practice, and it's becoming increasingly good practice as this thing gets bigger and bigger. So you're in an organization, you have a Thesaurus. Why should you care about linked data? Basically, I'm not proposing anything radical. All I want to do is take the terms in your taxonomy that have a corresponding concept in DBpedia, add a field to your Thesaurus or taxonomy to hold an external link, and add a URI to it. Once that URI is there, you can go and extract information from around the web associated with that term. In order to get linking back, as I just described, you have to edit Wikipedia or do something else to get crawled and add it to the wiki page external link field in DBpedia, so that when people go to get resource from the web, your resource shows up. Okay, so that's great. So we want to go through your entire taxonomy and look them all up in DBpedia and see if there's a corresponding concept and add a URI. Many of you probably have very large taxonomies or thesauri, for which this would be a daunting task. So there has to be some way to automate this. Well, of course there is. So we're going to describe some of the technology and techniques that we use to do this, and we have executed a proof of concept of this with a large scholarly publisher. So what are we going to use for this? We're going to use Wikipedia, DBpedia, and something called DBpedia Spotlight, which I'll explain in a second, and then we're going to use some human QCing on top of all that. You all probably know about Wikipedia, but I have a couple of slides here. There's a great deal of information in Wikipedia which has links to external pages. And so we can extract the structure from the Wikipedia into the DBpedia pages. Wikipedia is very, very large. 76,000 authors. This is from almost a year ago. 4.8 million articles and 3.2 billion words in Wikipedia. It would take 11 stacks to fit the whole thing in, 6 DVDs or a Blu-ray disc, or of course, one small card. And it's growing exponentially. So there's a ton of information in there. And the idea behind this is to leverage that information. Here's a sample Wikipedia page about bears. Here you can see the abstract or definition about the bear, and here in this little box over on the side, and you're starting to see these come up in Google searches where you look for a concept or a topic or a person, and a little box pops up with sort of the vital statistics. It's almost like a baseball card. So this one gives you the scientific classification taxonomy of the bear, down to the genre, and some other information. And you can see here where it says phylum Chordata, in the back of that, even though you can't see it, it's actually structured. It's a SCOS field, and that's how DBpedia can pull the information from Wikipedia in a structured way. So DBpedia is a crowdsourced community effort to extract structured information from Wikipedia and make it available on the web. Further, it's designed in such a way that it allows you to ask sophisticated queries about Wikipedia that you couldn't ask from a plain old unstructured natural language repository of information. And the goal of DBpedia is a little bit noble, which is to connect information on the web and inspire new mechanisms for navigating and linking Wikipedia. So now we're to the DBpedia page for Bear. You can see that the abstract page is exactly the first paragraph that we saw on the Wikipedia page. So how do we get that out of there? So DBpedia Spotlight is an API service that you can install. It's free. You send texts to DBpedia Spotlight, and it returns what it thinks are the most likely matches of DBpedia page for it. So they call it, this is from their literature, an entity linking tool for connecting free text to DBpedia concepts through recognition and disambiguation in the free text. So you send it a paragraph about bears, it will come back and say, we think this paragraph is about bears, and whatever else is in the paragraph. However, DBpedia Spotlight uses context for disambiguation. The more text you give it, the better it's going to do, because it looks at word proximity and semantic relationships in order to determine what kind of bear you're talking about, or whatever other word. I'll talk about this a little later because this becomes a little bit problematic for us. Spotlight runs as a service on a network. If you're going to process a lot of records at once, you have to give it a little time to chunk through. It is kind of a big thing, so it takes about 4 minutes to start the server and takes 13 gig of RAM for the stored table. So it's not a resource-friendly operation necessarily, but you don't have to have it up and running all the time. So what we're going to do is use DBpedia Spotlight and use the terms from your taxonomy or thesaurus as the input text, send them to the API for DBpedia Spotlight, and have it return what it thinks are the relevant terms from DBpedia. Then we can take the URI that it returns and add it to your taxonomy. You can also search a body of content for candidate terms. So if you're developing a taxonomy, you can send free unstructured text to DBpedia Spotlight, and it will come back with DBpedia terms, which you might want to consider for candidate terms for your taxonomy. Although that's a little out of the scope of this application, I still thought it was worth mentioning. So what we did in our proof of concept was take a branch of a thesaurus and use each term as a separate input string. So for each term, we're trying to find a matching DBpedia concept. So if we take the word optics and send it to DBpedia Spotlight, it comes back and says, hey, that looks like optics. And so for a lot of the terms, it's really not very problematic. Optics is not a very ambiguous term. Once it returns optics, now we have the URI of this DBpedia page, which is stable, and then all we're going to do is, I'm going the wrong way, all we're going to do is add it to a field in the thesaurus. Now we have another field in your thesaurus that has an external link to the DBpedia URI. So if you ever want to pull information from the DBpedia URI, you have the link there for every concept. Again, going back to another use for DBpedia, which is slightly outside the scope, but it was worth doing, is if you have a lot of unstructured content, you can send it to Spotlight, and it will tell you what concepts it's finding in that big pile of content, which then you can send as candidate terms to your taxonomist, which makes him or her very happy and allows them to add terms to your thesaurus. Why do we want to add a URI to our taxonomy or thesaurus? I mean, it sounds nice, but what are we going to do with it? Well, once it's there, we can add information to the thesaurus. Let's say you have a large taxonomy of thousands and thousands of terms, and you want to add definitions for all those terms. Maybe you have a landing page where someone mouses over a box, it pops up a definition. But typing in definitions for thousands and thousands of terms is obviously an extremely time-consuming and labor-intensive task. If you have links established to DBpedia, you can just query the abstract off and add it to a field automatically, and then offer that as the definition for your term, and other things like that. You can link out to other data sources. The BBC does a lot of things like this with linked data, where if you go to the BBC wildlife website and look up wombats, you'll get a bunch of BBC content about wombats. Pictures and videos, atomized articles, scientific definitions and things. And then the rest of the page, using linked data concepts and techniques, you get a bunch of other stuff about wombats that's not from their website, and they don't curate that content, they curate the links. So you might get a Twitter feed about wombats, a CNN news feed about wombats, a Google image search on wombats, or content about wombats from National Geographic or some other source. So linking to other data sources allows you to enrich your content or your content portal with media and information from other sources that you don't have to curate, as long as you make sure those links are good. And by the same token, because of all the structured information that came from Wikipedia that's included in DBpedia, like links, external resources, photographs, and references, you can recommend references on the topic. So if you have a page on optics or bears or wombats, you can recommend further reading to your readers without ever curating a reading list, as long as you have the appropriate link data URIs in place. And that could go to, as I said, Google Scholar, Twitter, image searches, anything that you can think of. So in the use case that I described, where we want to add an abstract to the thesaurus, we have a term optics, we have the URI for the term. We can now query off of DBpedia, and they make these tools available. This query system is already set up. Sparkle endpoint will work for you to extract that property, because you have here the name of the property field next to the box, pull that out, and then add it to a field in your thesaurus for the definition or the abstract that then you can pull out whenever you're serving up content. Maybe you have inline tags on your content where concepts aren't just tagged to a document or piece of content, but the place in the document that they're found. So in this sample article that I pulled on your awesome research website, where the word optics is, it would become highlighted because it's tagged in line. Now that you have a DBpedia link, if someone mouses over or clicks on that highlighted term, you can pop up the definition abstract, images, external references, or anything else that you can query off of your DBpedia page. You could also use it to launch a search, redirect to your topic page or someone else's authoritative topic page that you have decided, launch an image search, or use any other information that's curated on the DBpedia page for that topic. Such as recommending further reading. If you're interested in optics, you might want to check out OSA and SPIE. Seems fairly sensible. And then, as I described, in the case of the BBC Wildlife, you can offer external content pulled from other resources around the web on your page, as long as you have all your rights situations and all that figured out beforehand. On your awesome research website, on your optics page, you have your articles, and then you have results from Google Scholar on the same topic. You can have a Twitter feed search results, a Google image search, a list of journals on that topic, and other stuff like that. So your content can be merged with external content to create rich research portals for your users that go beyond the stuff that you have because you've curated these data links. And then, somewhat idealistically, when you connect your data set and through your vocabulary to other vocabularies on the web at large, you're putting your data set in this big bubble graph with DBpedia in the middle, and all these other things added to it, which include scholarly publishing things, government, vocabularies, mesh, all these other things. Once you establish the data links and set the backlinks up, now your bubble is on the big bubble graph with everyone else's, and all the data is beginning to come together, curated by taxonomic concept, by topic, in the big web of, the semantic web, as they say. So let's talk just for a minute about triples, triple stores, and ontologies, because this is stuff that comes up when you're talking about linked data and the semantic web. DBpedia, those pages that we've been looking at, even though you can't see all the predicates, are basically stored in triples. A triple is a simple statement composed of two objects, a subject and an object. I probably should have used better words there. Two concepts, a subject and an object, connected with some kind of predicate. So you might have these following sentences or statements about Ben Franklin. Ben Franklin invented bifocals and these other things. Ben Franklin was born in Boston. Ben Franklin held the position of Postmaster General, and so forth. Once you set up a list of triples about this, like about your content, so you might say, document 1, 2, 3, 4, 5 has topic optics. Then you can begin to build your own bubble graph out of a combination of your vocabulary and your content in a full-blown ontology. And so without having to understand how all these things work, this is the driving force behind linked data structures. And without having to do a bunch of work like this, you can still get your vocabulary hooked up by using the techniques that I talked about. So for example, I put together a sample ontology for a prospective customer that was about cooking pot roasts. And you can see that the subjects are concepts in your taxonomy, and that once you link them all together, now you have a nice little colorful bubble diagram which shows all the things that are involved in making a pot roast. That was a little ancillary, but I wanted to throw a couple words in there about triples and triple stores at the end. See, we took about half an hour, and I'm happy to answer any questions. Heather, are you taking questions? Well, I see here that I have one question from Jan Matson, who asks, can we trust Wikipedia as an authority of information? That is an extremely important and fair question. Wikipedia has gotten a lot better over the years. It used to be very unreliable, and no one would cite it in a scholarly paper. That has changed a lot. And lots of the sections have been curated by experts. And a lot of the information is very reliable. However, anyone can edit Wikipedia. We could go into that page on optics or bears or wombats right now and change the abstract and save it, and it would update right away. So there's a good faith community building effort involved here, that the structured data that we're pulling off is actually accurate. I expect it to get better as time goes on. Okay. We expect it to get better as time goes on, but for now, that's what we have to work with. The thing is that there are other linked data resources on the web. DBpedia is by far the most used linked data source. Other ones are less complete. You can link directly to someone else's vocabulary and skip the middleman if you want, but that sort of defeats the purpose of having a centralized location where everything is contained. I'm trying to unmute Heather. I don't seem to be able to do it. So while I'm trying to do that, let me say one more thing, which is that if you have a rich taxonomy, a deep taxonomy in whatever your area is, whether that's bears or optics or wombats, or whatever the specialization of your library is, your taxonomy is more granular than DBpedia is. It will have concepts that DBpedia doesn't have a corresponding page for. So DBpedia has a page for optics, it has a page for nonlinear optics, it doesn't have a page for photonic metamaterials. Nonlinear optics is still probably, maybe there's something called optical materials. So sometimes you have to come up with the next closest match, and it might be a broader concept that you've already matched. So almost guaranteed in the proofs of concept that we've done that your vocabulary is going to be more granular than DBpedia is at the current time. I am still trying to figure out how to unmute Heather so I can hear her. Thanks, Heather. So Heather wrote in the chat window, if you don't have it open, please submit your questions in the chat window while we figure out how to unmute her. And I'm working on it. Even though it says I'm Heather, Heather's really SLA unit webinars. But I didn't start as the presenter, so why can't I unmute her? there a list of attendees? Oh, sure. So I got a question here from Heather. So one of the things that we did when we did a proof of concept trying to link DBpedia terms to an existing thesaurus, we took a branch of a thesaurus. It happened to be a psychology branch. And we ran them through DBpedia Spotlight, and then because we didn't know how well it was going to work, we hand QC'd all the results. Heather, I don't know how to unmute you here.
Yeah, let me see.
There's no place. I'm not the organizer.
Oh, shoot. Okay, well, you have a question. This is from Sharon Garrowell.
Yeah.
I'll keep trying it from my end.
Okay, you should be able to unmute yourself. You're the organizer.
Yeah, it's not working.
So anyway, sorry. So we were going through these results from the psychology branch from DBpedia, and a lot of them did very well. Things that are less ambiguous, names of psychological conditions, usually came up in the top couple of results. In fact, over 85% of the time, that one of the top 3 results was the correct match to the DBpedia concept, and only about 2% of the time did we get some kind of noisy match. The rest of the things were ones that did not have a correlation in DBpedia. Some of the noisy matches were hilarious, and they must be driven by use case or something, because fear, which seems like a pretty unambiguous concept, the top match for fear was not fear the emotion, it was Darth Vader. So after having a good chuckle at that, we threw out that link and used the link to fear the emotion. If you understand a little bit about how DBpedia organizes its concept names and URLs with underscores and parenthetical disambiguators, it might help you with your input. Okay, I have another question from Jan Matson, which is, there seems to be a big jump from linking the semantic web to defining one's own triples. How much effort is required to set up a triple store and to publish our own ontology? You can publish any taxonomy or thesaurus in triples as an ontological structure, but not all of the relationships will be as well developed as a full-blown ontology. So if you think back to my pot roast slide or my Benjamin Franklin slide, they weren't just broader terms and narrower terms and related terms. It was Ben Franklin invented this, and you know, browning meat causes a Maillard reaction. So those more complicated predicates, besides broader, narrower related terms, once you expand into defining the relationships between concepts more granularly, that's the part that takes a lot of time. Publishing your taxonomy as an ontology in SCOS or OWL is a fairly simple matter, but getting it to actually leverage and take advantage of all the relationships in SCOS and OWL by customizing or using well-defined W3C relationships between those terms, you might have to go through your entire taxonomy and say, you know, carrot is a vegetable, Maillard reaction is a, you know, cooking concept, browning is a cooking technique, and define those relationships all the way through every relationship in your vocabulary, and then when you re-export it as SCOS or OWL and make it available, you'll have a full-blown ontology. However, as Jan says, if you establish the URI links and just export or publish your thesaurus in SCOS or OWL, you're essentially a lot of the way towards it. All the other people out there can use and link to your stuff. You just don't have all the relationships necessary for the querying ability that a full-blown triple store provides to you. Tanya Bequis asks, if all I want to do is make my taxonomy available to the semantic web, as opposed to linking each concept, what steps should I take? So then I would recommend publishing your taxonomy in SCOS or OWL. They both have advantages and disadvantages. But they're both very widely used. You might consider doing both. And putting it somewhere that it's accessible. The trick is figuring out, letting other people figure out that it's there. So there are places on the web that you can post taxonomies and other vocabularies that people go look for them. We maintain one called Taxobank. There are other registries of ontologies that people can go search when they're looking for existing vocabularies on specific topics. And so publishing in one of the 2 triple-based formats, RDF formats, and then getting it listed on one of the repositories where these things get listed is the first step. Elizabeth McLean asks, is there a good starting level of intro aspects of linked data that you can recommend? Yes, there is. There's a book that's just simply called Linked Data, and I will effort to get the reference to the book up here. I ran into the guy at a data conference a couple of years ago in San Jose, and I will get you his name. And it's very practical book. Linked Data books. And his name is David Wood and two other authors, and the book is simply called Linked Data. Linked Data. Yep. I'm trying to get you publisher information. It's on Amazon. If you look up Linked Data book, it's always the first or second one, and David Wood is the first author. There are two other authors on it. Good book, very practical, but also packed with sort of historical background to the information theory concepts that are being described. Very, very interesting. Highly recommended. Oh, so we never got Heather's voice back on, but she's on the chat. If no one else has any questions at this time, please feel free to contact me. We'll make these slides available on the SLA Rio Grande site. I think that's correct. My email address and little used Twitter handle are down here. And I'm always happy to talk about linked data or any kind of semantics like that. Thank you so much for joining us today for our SLA webinar. I've enjoyed it. I hope we got enough time to answer your questions. Oh, I have one more question coming in. So the question is coming. Currently, our taxonomy is in NCBO BioPortal, but I was thinking of your comment about backlinking to DBpedia. What does that entail? So backlinking to DBpedia involves editing Wikipedia to add a link back to the appropriate page on your site. However, in having done a few proof of concept stabs at this kind of work, it depends on what your link goes to. People go through and curate those things, and when I was doing it, they decided my stuff was link spam, even though I thought it was a completely relevant link to add to Wikipedia. So the trick is getting a, quote, legal link in Wikipedia that then gets crawled and linked back to DBpedia. So they seem to like specific articles better than they like topic pages on portals, but that doesn't make any sense. So I don't know what their policy is on that, but I'm trying to get some clarification and refinement on how that might work. And then I have a question from Becky. What about taxonomies behind firewalls or paywalls? I think some of those portals, like the NCBI BioPortal, although I'm not sure about that one, list vocabularies, even if they're not freely available. If you have to license, buy, rent, or somehow get access behind a firewall or a paywall, some of the portals that list vocabularies, either in general or in a specific topic space, there's essentially a field or a column in the listing for whether it's freely available, whether licensing is required, whether it's free or some kind of access. Just looking to see if there's any other questions. Yeah, I got that one. Okay, I think that's all for today. Thank you so much for tuning in and listening to me talk about linked data. Please reach out to us if you want to talk about linked data some more, and we'll see you at the next SLA webinar event. Yes.